and it can accelerate a 2-ton car to 60 miles an hour in 2 seconds. The RPM is so crazy that just the centrifugal force wants to expand the rotor.
This is truly an incredible feat of engineering. Nothing like this electric motor has ever existed before. You can literally lift this motor with your hands, yet it has enough power to launch a 2-ton car from 0 to 60 miles per hour in just 2 seconds. When Tesla unveiled its new motor, every major automaker went silent. There were no press conferences, no public criticism from engineers, and no promises of a better alternative coming soon. The people whose job is to analyze competing technology looked at what Elon Musk's team had created, and instead of responding, chose silence. That silence spoke volumes. In an industry where every product launch sparks immediate reactions, where competitors rush to brief journalists and reveal future plans to steal attention, the lack of any response after Tesla's announcement became a statement itself. It showed that experts had studied the numbers and understood exactly what they meant. Sandy Munro, an engineer and manufacturing expert who has spent years analyzing electric drive systems, recalled seeing the specifications as they spread through engineering circles. He stopped in disbelief. The figures didn't seem possible. Not in a practical family sedan with a back seat, cup holders, a warranty, and a price that everyday buyers could actually afford. Known for taking vehicles apart and pointing out every flaw, Munro rarely hands out praise. Yet after examining Tesla's drive technology, he expressed genuine respect mixed with concern. He understood the significance of what Tesla had achieved long before the general public did. To appreciate Tesla's breakthrough, you first need to understand the challenge it solved. Every electric motor contains a rotating part called the rotor. As the motor runs, the rotor spins at extremely high speeds. The faster it spins, the greater the centrifugal force pushing outward, constantly trying to tear the rotor apart from the inside. Engineers have always treated this as a battle against physics. If the rotor spins beyond its limit, it begins to deform, loses its precise shape, and can fail completely. For decades, this physical limit shaped the design of every electric motor. The industry accepted it as unavoidable. Tesla didn't. Its solution sounds simple, but is incredibly difficult to execute. Tesla wrapped the rotor in carbon fiber, one of the strongest and lightest materials ever developed. The carbon fiber acts like protective armor, applying inward pressure that counters the outward forces created during high-speed rotation. This keeps the rotor stable at speeds that would destroy conventional designs. As a result, the motor can spin at over 20,000 revolutions per minute, a speed normally associated with industrial turbines rather than passenger cars, while maintaining the precision required for maximum efficiency. The biggest engineering hurdle was thermal expansion. Carbon fiber and copper, the rotor's main conducting material, expand at different rates as they heat up. If the carbon fiber is wrapped too loosely, the changing temperatures reduce the tension and eliminate its structural advantage. Wrap it too tightly, and the rotor can fail during manufacturing. To overcome this, Tesla had to invent an entirely new machine to build the rotor because no existing equipment could do the job. The process demands extremely precise tolerances and carefully controlled winding tension. That manufacturing system became a valuable piece of intellectual property, making the production process itself as important as the motor it creates. This is why competitors who fully understand the motor's design still cannot copy it at production scale. Knowing how something works is very different from manufacturing it reliably, efficiently, and at a cost that makes commercial sense. Tesla solved both challenges, while much of the industry is still trying to solve the first. The most obvious proof of this breakthrough appeared in the Tesla Model S Plaid. Its performance stunned engineers and automotive journalists alike. The car can accelerate from 0 to 60 miles per hour in less than 2 seconds, delivering a level of performance that many experts still describe as difficult to comprehend. That level of acceleration is usually reserved for purpose-built race cars designed for one thing only: maximum speed. These machines sacrifice comfort, storage, and practicality. Yet the Tesla Model S Plaid delivers the same performance while comfortably seating 5 adults, carrying luggage, offering a smooth ride, and traveling hundreds of miles on a single charge. In doing so, it shattered one of the industry's biggest assumptions. For years, automakers claimed an electric vehicle could deliver either high performance or long driving range, but not both at the same time. Tesla proved that belief wrong, and no press conference could erase that demonstration. Imagine an automotive journalist with 2 decades of experience testing high-performance cars. Someone who arrives at launch events expecting nothing surprising. Then they drive the Plaid, press the accelerator once, and their calm, professional expression instantly changes. That same reaction played out again and again across automotive media outlets around the world. The industry saw those reactions and stayed silent because there was little left to argue. But the story became even more significant when the manufacturing costs came into focus. Performance is only part of the equation. The real challenge is building that performance efficiently enough to change the market rather than remain an impressive prototype. Tesla revealed that its next-generation drive units are designed with manufacturability as a core objective, not something considered after the engineering is complete. From the beginning, performance and production cost have been treated as equally important goals. The company's target is to build an entire drive unit, including the motor, power electronics, gearbox, and complete system, for about $1,000. That number landed like a shock across the automotive industry. Many competing drive units cost 3 to 5 times more to produce. Closing that gap isn't possible through better supplier deals or small manufacturing improvements. It requires rethinking the entire system, how it's designed, sourced, and assembled. And that's not something competitors can copy simply by studying the finished product. The real advantage comes from years of manufacturing experience, constant refinement, and countless behind-the-scenes improvements that never make headlines. Even cost analysts at traditional automakers, whose job is to reduce expenses by a few dollars per part, found no simple answer to Tesla's $1,000 target. There is no spreadsheet capable of solving a gap that large. Bridging it means rebuilding the entire system from the ground up, a process that takes years and offers no shortcuts. What makes this breakthrough even more important is the timing of its release. Tesla wasn't revealing this technology from a position of complete market dominance. Cybertruck sales had fallen well below the expectations created during its high-profile launch. Reports also suggested that in some periods, a noticeable share of registrations came from companies linked to Elon Musk rather than independent retail customers, raising questions about genuine market demand. Meanwhile, every major automaker had accelerated its electric vehicle programs, investing billions of dollars and assigning thousands of engineers to compete in the market Tesla had created. Much of the financial and automotive media portrayed Tesla as an early pioneer that was beginning to lose its lead to larger, better-funded competitors. It was during that period that Tesla introduced a motor that made rival technologies appear generations behind. Whether the timing was planned or simply fortunate, the impact on the industry was undeniable. The competitive advantage becomes even greater when this motor is viewed alongside Tesla's broader ecosystem. Every Tesla on the road continuously gathers real-world driving information, including road conditions, driver behavior, weather, traffic patterns, and unexpected situations that challenge autonomous driving systems. That massive stream of data feeds directly into Tesla's artificial intelligence, allowing its self-driving technology to improve continuously instead of waiting for occasional software updates. The company has collected driving data from icy roads in Scandinavia, crowded streets in Mumbai, and desert highways in Arizona. An unmatched dataset that cannot simply be bought, licensed, or recreated through controlled testing. That advantage can only be built through years of real-world driving, 1 mile at a time. Any competitor starting today isn't just behind Tesla. They fall further behind every day because Tesla's fleet keeps expanding while theirs is still growing. Its data advantage continues to compound alongside its manufacturing and motor advantages. None of those advantages can be overcome using the traditional strategies companies rely on to catch up. The experience of Ford and General Motors shows exactly what happens when one company gains a major cost advantage. Both companies produced capable electric vehicles. Ford introduced the Mustang Mach-E and F-150 Lightning, while General Motors launched several EV models. Yet reports suggest they still lost significant money on every vehicle sold. Lucid Motors developed premium EVs with impressive range, but burned through cash at an unsustainable rate. Rivian attracted enormous investment and attention, but spent years struggling to lower production costs enough to become profitable. The pattern was consistent across the industry. The technology was solid, the vehicles were real, but the economics remained extremely difficult. At the same time, Tesla wasn't just matching or outperforming competitors. It was pushing toward a $1,000 drive unit, making its manufacturing cost advantage even larger over time. That's what creates silence in boardrooms. Competitors can clearly see what Tesla has achieved. They understand its significance, but they lack a realistic plan to close the gap before it grows even wider. The battery story follows the same pattern. Tesla invested billions in developing its own 4680 battery cells to increase energy density, lower production costs, and simplify manufacturing compared with its earlier battery design. Most EV makers still depend heavily on outside battery suppliers, meaning their costs are tied to supplier pricing instead of their own manufacturing improvements. Tesla's growing vertical integration in battery production means every improvement in its manufacturing process directly lowers vehicle costs. As production scales up, that advantage becomes even stronger. The same approach applies to chip design, software, and power electronics. When the global semiconductor shortage disrupted the auto industry, Tesla adapted far faster than most competitors by rewriting its vehicle software to work with different chip configurations. That flexibility existed because Tesla designs its own chips and develops its own software. Companies relying on outside technology partners simply don't have that level of control. The supercharger network adds another advantage that many people initially underestimated. For years, critics viewed Tesla's charging network as a convenient feature rather than a major strategic asset. They were wrong. The supercharger network became one of Tesla's strongest competitive advantages because it's fast, dependable, widely available, and consistently reliable, qualities many competing charging networks have struggled to match. Eventually, even Ford and General Motors acknowledged that reality by adopting Tesla's charging standard, giving their customers access to Tesla's network. It was a public admission by century-old automakers that they couldn't match what a much younger company had built. Think about what that decision really means. Companies with their own engineering teams, technical standards, and decades of infrastructure experience concluded that the smartest move wasn't to compete. It was to join Tesla's system. That choice also allows Tesla to earn revenue whenever another company's electric vehicle charges at a supercharger station. Every compatible EV sold by any manufacturer can generate income for Tesla whenever it uses the company's charging network. The real threat isn't the carbon fiber rotor itself. It's the system that made it possible. Years of manufacturing improvements, the constantly growing data advantage, deep integration across batteries, chips, software, and charging infrastructure, all working together as a self-reinforcing ecosystem that delivers new breakthroughs faster than competitors can copy the previous one. Even under the most optimistic estimates, copying the motor alone would take years. Recreating the entire ecosystem that made the motor possible and is already driving the next breakthrough is an even greater challenge. That is what the engineers understood when they quietly examined the specifications. They weren't simply looking at a motor they couldn't match right away. They were seeing proof of a development process they couldn't replicate. A self-reinforcing cycle of innovation that becomes stronger and faster as it continues to grow. If this video changed the way you think, imagine what the next one will do. Subscribe to Alpha Discovery.